Hey, I'm Clay. I'm a data scientist at Expose. And on this episode of Purple Peeps Talk, I want to chat to you about a cool ML and AI project that we've been working on recently in regards to speech classification in the health industry. We had a client come to us recently and they said, look, we're running different training programs for different medical staff, in hospitals, GPs, labs, and all of that kind of thing. And they basically have these referees that walk around and follow the staff and make sure that these staff complete a number of different tasks within training modules before they become accredited in, said thing. But the problem is that these referees who are supposed to mark these staff as, passing or failing in these certain accreditation modules, because they're quite, high up, they're not just responsible for the training, but they oversee lots of different aspects of the hospital and GPs and labs and those kind of things, during a given day. So what would happen is they would follow all of these staff around and they would do their day-to-day tasks, and it would get to the end of the month and these referees would have to mark off certain criteria for these employees, but they would find it difficult to remember the certain situations where the employee demonstrated said skills, right? So the client came to us and they said, look, we need to develop some kind of solution where a referee can pull out their phone, record a voice memo about the certain situation, and we want it to automatically transcribe and map to a staff's training record. And I said, of course, let's work together, explore some different solutions, and basically determine if this solution can be feasible or not. So before we jump into the solution and how we determined if this was feasible, there are basically two different problems that we need to solve here, right? So the first thing is, how can we use voice notes to record a referee's feedback? And the second thing is, how can we automatically classify them to the correct training modules? Because we want to save time and make sure that the referees who are already busy don't have to go through and manually map all of those things. So I said to the client, look, I'm going to need a couple of things from you. I'm going to need the referee's voice recordings, for a couple of different staff, and then going to need to know which voice recordings map to which training modules in order for me to train an algorithm or a model to automatically classify them, right? So the client gave me these things, and the first thing that I decided to do is pass the voice recordings through a pre-trained model. So I bet you're asking me, Clay, that sounds cool, but what's a pre-trained model? So a pre-trained model is a model created by someone else to solve a similar problem, right? And the problem that we're trying to initially solve is converting the voice or the speech to text. And this is something that, it's quite common. A lot of people do this, in speech to texting all the time. You would have seen it before. And so there's no point in me creating one of those algorithms from scratch. Let's piggyback and reuse another one. But the problem is for us is we need to make sure we observe these edge cases like, busy hospitals, difficult medical terms, accents, and all of those kind of things, right? And in regards to using a pre-trained model, there are obviously the biggest cloud providers like GCP, AWS, and Azure, and lots of different other niche services provide these options. And so what I did is I passed them through most of these, but what I found is that Azure Cognitive Services APIs provided me with the best results. So basically what we did is we took the client's audio files, we passed them through the pre-trained models hosted on Azure Cognitive Services, and we were provided with some excellent results like this, like you can see on the screen. It gives us things like confidence scores on individual words, so we can compare them for the medical terms that we're trying to look for. You can differentiate between different speakers, and it also provides us with different speech to text algorithms so we can pick the one that works best for us. So we ticked off the first problem, which is trying to convert voice recordings into text, which can be given to the staff members for, tangible feedback in their training modules instead of just a checklist or something like that, right? So the next step for us is to do the classifying into the different training modules. So in order to do that, we need to do something called feature engineering. So feature engineering is the process of selecting and manipulating and transforming data into features that we can use in our machine learning algorithms. In the case of this scenario, before we can determine if these audio files match to a certain training module, we need to convert the text basically into numbers, right? And there are a few ways we can do that. So these are the pre-processing methods that we're going to apply for the text that we have. Vectorization, TF, IDF vectors as features. word embeddings as features, and text NLP based features. So the first one that we'll apply is vectorization. And vectorization is basically converting input data from its raw format, for us it's text, into vectors of real numbers, which is the format which is the ML model support. The next one we're going to do is term frequency. So term frequency calculates the number of times a term is mentioned in a document. And we can also do this not just for words, but also n-grams and characters and all of those kind of things as well, right? So word embedding is similar to vectorization, but a word embedding is a learned representation for text that have the same meaning for a similar representation. For our word embeddings, I basically downloaded every word topic from Wikipedia and I trained it against that. So lastly, we can convert basic word features as well. So we can look at the word counts, the character counts, the word densities, and the frequency distribution of these verbs and adverbs and all of those kind of things as well, right? So basically, we apply all of these pre-processing techniques like I've mentioned, and then we're given a bunch of numbers, right? And these are the numbers that we can use to input into the different machine learning algorithms. So this is basically what we're left with. We have the mapping file, we have all of the outputs from our pre-processing, the labeled recordings, and this is basically all the information that we need to input into the different machine learning algorithms to determine if we can classify in the voice recordings into the correct subjects. So the most common models built with machine learning generally fit into categories of regression or classification. Since we're trying to determine if a voice recording belongs to a certain training module, we'll be working with classification like you can see down the bottom. So I basically passed the data through a large number of different classification algorithms. And these are some of the ones that I use, logistic regression, native Bayes, and all of that kind of thing. I won't go into depth about how these algorithms work for now, but I've just put them on the screen. So if you want to Google them later, you can see how they work. So basically, I put them through the model and I got some results from the model. And in order to determine their effectiveness for this scenario, we need to look at these different metrics. So accuracy represents the number of correctly identified cases. Precision is the ratio of correctly positive observations over the total predicted positive observations. Recall is number of correctly predicted positive observations over observations in the actual class, and F1 score is a weighted average of precision and recall. And this is one of my favorite diagrams where we can basically look at how accuracy works, how precision works, and basically the outputs of the model are not always as it seems, right? We can't just use one metric for all cases. We need to look at the different things like F1 score and precision and recall. I won't dive into the accuracy and the F1 scores for the models that we produced. But basically, the results showed that the algorithms worked well for the majority of most classes that we're trying to predict. And we're able to do it with a high accuracy and a high precision. There were a few educational categories that we found it quite difficult to match the voice recordings to. But what we did is we did a analysis on the sample sizes, and we found that if we were to provide them with more examples or more voice recordings for these classes, we'd be able to actually get a greater accuracy. So we went back to the client and we discussed our results, and we brought it back to the core problems that we're trying to solve. The first one was, can we use our voice notes to record the referee's feedback? And we found that using Azure Cognitive Services, we could easily convert the speech to text. And we could also work through some of those difficult edge cases like medical words and accents, and it seemed to work quite well. The second thing was, can we automatically classify them to the correct training modules? And we found that after passing the augmented data through the different machine learning algorithms, we were able to classify the voice recordings to the correct training modules. But, with the exception of a couple difficult cases, some of them required a couple more training samples in order to work a bit better. But overall, we were able to solve and determine that both of these problems were quite feasible. So overall, this was a really fun solution that we worked on, and hopefully you found this as exciting as I did. Some of these solutions may seem difficult to bring into reality, but as the technology progresses, the edge of what is possible basically moves out, and as allows us to build, more difficult things. Then the client was happy with these results. We were happy with how these results turned out, and it was quite a feasible solution, and it was really fun to make. So thanks for watching. Hopefully you guys learned something, and I'll see you guys next time.